These firefighters are not racing toward an accidental wildfire. They are starting a real fire on purpose. The footage is authentic. Trained crews are carrying drip torches through a planned burn, while other firefighters hold the boundary. The idea sounds backwards, but the target is not the living forest. It is the connected layer of dry grass, needles, brush, and fallen branches that can feed a much larger fire later. A prescribed fire trades a smaller, planned fire today for less fuel under a future wildfire. That trade is useful only when the place, weather, crew, and escape plan all fit a written prescription. Wildfire danger is not only about whether something can ignite. It is also about how much fuel exists and how continuously that fuel connects across the ground. One burning twig may go out. A continuous carpet of dry needles can carry flame from shrub to shrub and into taller vegetation. Prescribed fire interrupts that path. Low flames consume selected surface fuel before a hot, dry, windy day can turn the same material into a faster fire. This does not make the land fireproof. It can reduce the quantity and continuity of fuel, which can lower potential fire behavior and give responders a more workable place to engage. The word prescribed is literal. Before ignition, managers define an acceptable range for wind speed and direction, temperature, relative humidity, fuel moisture, expected flame length, smoke movement, staffing, equipment, and containment lines. If one critical condition falls outside that range, the burn can be postponed. Crews often begin with a small test fire. They watch how quickly it spreads, where the smoke travels, and whether the actual behavior matches the plan. The operation proceeds only after a go decision. That is why a calm-looking morning matters. Fire behavior is being chosen inside a narrow window, not improvised after the first flame appears. A drip torch does not simply pour fire everywhere. It lays a planned line of burning fuel. Crews can ignite along an existing road, a scraped line, or another boundary where the fire can be held. A backing fire that moves against the wind is usually slower than a head fire pushed with it. Ignition teams and holding teams work as separate layers. One creates the pattern, while the other watches the edge, cools hot spots, and stops embers from crossing. As blackened ground grows behind the flame, that already burned strip contains less fuel. The changing shape of the burn becomes part of its containment. Fuel reduction is only one objective. In fire-adapted ecosystems, periodic fire can recycle nutrients, open space and sunlight near the ground, control some invasive plants, and create habitat conditions that certain native species depend on. But the result depends on the ecosystem, season, intensity, and interval. A treatment that helps one landscape could damage another. That is why the burn plan starts with a specific land management objective rather than the vague goal of burning something. The real question is not whether fire is good or bad. It is which fire behavior, in which place, at which time, produces an acceptable result. Prescribed fire still produces smoke, including fine particles that can harm air quality and people at higher health risk. Wind can shift, conditions can change, and planned fire can escape its boundary. Managers therefore plan smoke movement, public notification, contingency resources, and a point at which the operation stops. That limitation is the final clue in this footage. The firefighters are not proving that humans can dominate fire. They are choosing a smaller range of conditions in which fire is more predictable than it would be during an emergency. Burn some connected fuel now carefully so a future fire may have less energy to work with. Subscribe for the next real system hiding in plain sight.